So discrete random variable. So once if you take a random variable x as a discrete random variable, then we can build a probability distribution table for the discrete random variable. And for example, how to construct a probability distribution table, let us discuss by taking a small example. If suppose a coin is tossed for 3 times or flipped for 3 times, then the corresponding random variable, if suppose x is taken as getting ahead, then we can consider the values of x as 0, 1, 2, 3 based on the sample space. We can assign the values to the random variable x as 0, 1, 2, 3. Then the probability distribution table for the experiment of tossing a coin or flipping a coin for 3 times can be taken as follows. So before going to construct the probability distribution table, just we write the sample space here. First of all the 3 cases may be heads, all 2 heads, 1 tail, and tail head, and this is the next tail head, and finally no heads. So if this is a sample space, then we can assign the values for the random variable x as 0, that represents no head, this is the case, and only one head case, there are certain outcomes consisting only one head, similarly 2 heads, and exactly all the 3 heads. So for this, the probability distribution table we can define as x and p of x. So we can have the x may be 0, 1, 2, 3, and then the corresponding probability for x is equal to 0 is 1 by 8. So as the favorable cases is 1, getting no heads out of 8, and in the same way getting only one head out of 8 is 3 by 8. So that is one head, one head, one head, and similarly getting 2 heads is also 2 heads, 2 heads, and 2 heads. This is also 3 by 8, and getting all the heads we have only one particular case out of 8. So this is what we call as a probability distribution table for this discrete random variable x, which is representing getting the heads in an experiment of tossing a coin. Okay, and now we can have certain statistical parameters called mean, variance, and standard deviation. So first of all, we can have the mean for the random variable which is discrete can be given by the formula summation of all xi into p of xi. So in this experiment of tossing a coin for 3 times, and for the corresponding probability distribution, the mean can be determined sigma xi into p of xi for I is equals to, here we have 0, 1, 2, 3. So we can take the 4 values for that x, and in this way, that is, we can have 0. If I is 1, we can take x1. x1 represents the first value assigned for the random variable 0. So 0 into the corresponding probability 1 by 8 plus 1 into 1 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8, and this gives 3 by 8 plus 6 by 8 plus 3 by 8, 9 plus 1, 10 by 8. So 10 by 8, which is a mean of the random variable of the experiment, given experiment. And in the similarly, we can also define the variance for the same experiment if for the discrete random variable x. We can have the variance is given by the formula variance is equal to sigma xi into p of xi minus mean square. So here we can have this sigma xi square into p of xi minus mean square. So in this variance for the random variable x for corresponding experiment can be taken as 0 square into 1 by 8 plus 1 square into 3 by 8 plus 2 square into 3 by 8 plus 3 square into 1 by 8 minus mean square. Mean square is 10 by 8 whole square. So the corresponding value is the variance of the random variable x. So this we can write 1 into 3 by 8 plus 4 into 1 into 3 by 8 is 3 by 8 plus 4 into 3 by 8 12 by 8 plus 9 into 1 by 8, this is 9 by 8 minus 10 square 100 by 64. So we can calculate this to get the variance of a random variable x, which is discrete in nature. Okay, and here this how we can determine the mean variance, and the standard deviation for the same random variable x can be determined by using a simple process, formula. Always the standard deviation can be given by the formula of square root of variance. So this what we can the way we can determine the standard deviation. So to determine the standard deviation, first one need to determine the variance for the given corresponding values of the random variable x corresponding to the given probabilities. Okay, and now let us discuss a small problem by considering this how to determine the mean, variance, standard deviation and certain results for the given probability distribution table. Suppose this is what the have assigned with certain values like 0, 1, 2, 3, 4, 5, 6, 7, and the corresponding probabilities are 0k, 2k, 2k, 3k, k square, 2k square, 7k square plus k. So this what the table we are calling as a probability distribution table for the given random variable x. Now we are interested to determine certain things in the given probability distribution table. Here k is an unknown value, so first we determine the k, and the certain probabilities like probability of x less than 5, probability of x greater than or equals to 6, and mean, and even we can determine the variance, etc. So first, to know the determination of these kind of things, one should know the axioms of the probability. So here there are certain axioms of the probability. Basically, first the probable value is always positive. So that is the first axiom one should remember, and that it lies always between 0 and 1. The probability of every event is a positive and it lies between 0 and 1. And the total probability values of all the events of an experiment is always 1. That is nothing but the probability of sample space is always 1. So one should remember these axioms before solving these kind of questions. So let me determine one by one. So first let us determine the k value, which is an unknown in the given probability distribution table. So to determine the k value, we apply the axiom, probability axiom, that the total probability of all the values of x is always 1. So by considering this particular axiom, we can determine the value of k, that is sum of all the probable values in the given probability distribution is always 1. So that is 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k is always 1. So this gives that 7k square plus 2k k square plus k square, that is nothing but a 10k square plus, and here 2k plus 2k 4k plus 3k 7k plus k 8k plus k 9k plus minus 1, the constant, is equals to 0. Now by solving this equation, we can have the k values as a k is equals to minus 1 or k is equals to 1 by 10. So as we know that no probable value will be taken as a negative, so always it should be positive. So here we can consider the k as a 1 by 10, which is a positive value, and this is what the unknown k we can consider in this given problem. So now we have to remember k is equals to 1 by 10. So I am writing here the k value. Let us remember this for further determinations of all the remaining results. So k is equals to 1 by 10. So now let me go for the second question. So here the second one is finding the probability of a random variable x which is less than 5. So probability of x less than 5 we get which is nothing but it should be x is taking values up to which are less than 5. That means we can have the values of x up to 4. So here x may be 0, x may be 1, x 2, x is 3 and x is 4. So now let me have the probable values corresponding to each value assigned for the given random variable x. If here for x is equals to 0, the probability value is 0 itself as per the given table, and for x is equal to 1 we have the probability is k, and we know that k is nothing but, so first let me write k, and the second one for x is equals to 2 we have the probability is 2k, and for x is equal to 3 we have the probability as 2k, and for x is equals to 4 we have the probability as 3k, and which is nothing but 3k plus 2k 5k plus 2k 7k plus k 8k. So 8k which is nothing but 8 into 1 by 10 which is 8 by 10, and this is absolutely 0.8. So here the probable value which lies between 0 and 1 only. So the probability of a random variable x less than 5 is 0.8. And now let me go for the third question, that is the probability of x And now let us continue this the third result. Let us determine probability of x greater than or equals to 6. So the probability of x greater than or equals to 6 is given the probability of always x greater than or equals to 6. Here we can determine this probability by taking two different modes. One is x takes the values from 6 up to the last value, that is we can have that probability of x is equal to 6 plus probability of x is equals to 7, because x is taking the values only up to 7. For x greater than or equals to 6, x may take 6 as well as x may take 7, and so the corresponding probability of x is equal to 6 is 2k square, and probability of x is equals to 7 is 7k square plus k, and this part is nothing but 9k square plus k, 9k square plus k. So 9k square, 9 into 1 by 10 whole square, that is nothing but 9 by 100 plus 1 by 10. So by taking LCM 9 by 100 plus 1 by 10, we get 0.19. So this is the corresponding probability of the random variable x greater than or equals to 6. And here we can even determine the same thing by using a complement mode. How to get that? This is a x greater than or equals to 6, representing that x takes at least value of 6. At least value of 6, that means x may be 6 or more than 6. Here then we can have this part in this manner. We can even determine that for at least case always we used to go for the complement mode in the way of 1 minus of x less than 6. This is also one of the method we can use to determine such things, at least case. So this can be taken as 1 minus of probability of x less than 6, strictly less than 6, so that x may be 0, x may be 1, x may be 2, up to x may be etc. We can consider up to x will be equals to 5, and by considering all the probable values of x0, x1, etc. up to x is equals to 5 and subtracting from 1, even we can get the same thing here as a 0.19. So in the two ways we can even determine the probability of this x greater than or equals to 6. And now finally let me determine the mean for the given random variable x. As the random variable x is a discrete random variable, we can understand the mean of the discrete random variable is given by the formula sigma xi into p of xi. Xi into p of xi. For all xi takes the values, of course even you can take from 0 to 7, we can apply. So this gives nothing but 0 into this, I am just writing 0 into the corresponding probability, 0 plus 1 into the corresponding probability plus 2 into the corresponding probability. In the way we can determine 3 into 2k, 4 into 3k plus 5 into k square plus 6 into 2k square plus 7 into 7k square plus k. So by considering the k value as a 1 by 10, what we already determined previously, and substituting k value and evaluating this equation, and we may get this part is approximately 3.66, approximately 3.66. we may get the mean value by substituting k in this equation as a k is equals to 1 by 10. And by determining mean, Here one thing we need to remember, that the mean of the random variable, which is a discrete random variable here, is always denoted by a symbol mu. We usually denote the mean of the random variable as a mu. So here, once if you able to find the mean of a given random variable, even we can determine the variance of the given random variable, actually, which is given by the formula variance of x, the random variable x, which is denoted by sigma square, and is given by the formula sigma xi square into p of xi minus mean square. Mean square means mu square. So by considering square of a value assigned for x, 0 square into 0, 1 square into k, 2 square into 2k, 3 square into 2k, 4 square into 3k, 5 square into k square, 6 square into 2k square, and similarly 7 square into 7k square plus k. By finding this summation and subtracting the mean value what we obtained previously here, then it gives the value of the variance of that discrete random variable.